Hey guys, welcome back to my channel. I hope you all are safe and sound in this pandemic. So far we were talking about the Protest tutorial series where we have learned about lot of things like how to install Protest software, how to use different components like oscilloscope or graphs, or how to configure different components as per your requirement. So now we are going to start the Arduino tutorial series. We will write the code in the Arduino IDE and then we will simulate our circuit or test our circuit in the Protest software. So if you are new to my channel or you have not seen the tutorial series yet, so please watch that videos first. I have given the link for the playlist in the description box. So watch that series first. So let's get started. So this is our first video on the Arduino tutorial series. So first of all, I want to let you know that there are different boards in the Arduino series available like Arduino Mini, Nano, Mini Pro, Uno, and Mega. But we are starting this series for Arduino Uno. So here is our Arduino Uno board. So in this software, this Arduino board is self-powered. I mean to say that system is assuming that this Arduino board is powered already, so we do not have to we need not to add sources like VCC or ground here. So first of all, this is a microcontroller board, not a microprocessor board. Let's discuss the difference between the two. Difference between a microcontroller and a microprocessor. So I have created a simple block diagram for a microcontroller and a microprocessor. A microcontroller board consists of CPU, which is actually a microprocessor. A microprocessor connected with different external devices like memory, input output ports, and converters. And this whole combinations forms a microcontroller. A CPU or a microprocessor, without these external components, you cannot do anything with a microprocessor until you connect a microprocessor with the different components. But when you connect a CPU or your microprocessor with external components, for example, you are connected to a board. That means you are having a limited memory, limited number of input output ports, and a limited number of ADC or DAC channels or converter channels. That means you are allowed to do a certain limited number of tasks. If you want to expand the range of your tasks or expand the range of your controller, then you have to choose. Then you have to go to a different one. You have to choose a different microcontroller. But if you are having a microprocessor, that means you have an unlimited range of tasks that you can do with a microprocessor, but you have to connect this microprocessor with your external components. You cannot do anything without the external components. A microprocessor is the brain of your microcontroller board, which consists of a control unit which controls the whole microcontroller board as well as the CPU itself, program counter, register, and communication channels. Communication channels are used to communicate between the CPU or the control unit and the devices that connected to it. For example, you have connected your sensor. You have connected a sensor with your microcontroller board and you want to do some action or automation microprocessor. That means you need a communication channel to receive the data from that sensor, to send that data into the control unit, and then send the command to different actuators, for example motor or LED, anything that you have connected as actuator to do some work. Arithmetic logic unit, which performs the mathematical and logical operations, for example addition, subtraction, multiplication, and logical operations like comparison, etc. Program counter holds the address of the program that are written by the user or the programmer, and that program is stored in the registers that are available inside a microprocessor. So this is the block diagram of a microprocessor. If you are having a microprocessor, that means you have an unlimited range of tasks that you can do with a microprocessor, but you have to connect this microprocessor with your external components. You cannot do anything without the external components, like for example memory or converter. For example, if we are talking about the converters like ADC or DAC channels, as you know that our computer runs on digital signals, for example like 0 and 1. low or high. So analog signals are need to be converted into the digital signals so that our CPU can perform the task as per the requirement. So all these components are required for some memory input and converters, and there are many other components available like buses and interrupters, etc., that are needed for a microcontroller. So this is our Arduino board, which is a microcontroller board. The main thing on this board is its brain, which is this ATmega 328 IC or chip. This IC is of 28 pins and its pin configuration is here. Its pin configuration is here. So 14 pins are on the left side and 14 pins are on the right side. This block and this block shows the configuration of these pins as per the Arduino board. I will provide this link in the description box for this image, so you can study this pin configuration from there, and I will explain the pins configuration of the Arduino board. So the pin that are available in the right side of this Arduino board, pin number 0 to pin number 13, are the digital pins. Digital pins mean that they can only receive a digital input or can give a digital output. That means you can only use any pin from a digital pin either as 0 or low. There are certain more pins that like pin number 3, pin number 5, pin number 9, etc. are called the PWM pins. We will see their use later. These pins from pin number 0 to pin number A0 to pin number A5 are the analog pins. That means you can connect any component, any sensor which generates the analog output, and you can connect that sensor or that output to this analog channel. Sensors like flex sensor, LDR sensor, or sonar, etc. are the example of sensors that are generating the analog signals. And the sensors like IR sensor, position sensor are the examples of digital sensors, are the sensors which are generating the digital signals. So this is the USB port which is used to upload the program into this Arduino board or to power this whole board. This is the power board. This board is available. This board is also available to power the Arduino from an adapter circuit, and some certain pins are also here, which are like VCC, ground, and a reference, which are also used to power this component as well as to give the power to the external components. For example, you are connecting a sensor here which needs a VCC or ground, so you can power that component from here also. So this was all about this video. Thank you so much.